Pydantic AI's agent resolves function tools into structured tool definition, objects that carry name, description, and parameters JSON schema derived from the tool's signature and Pydantic model, making the model's callable interface explicit before any execution occurs. A single Foobar model class with 3 fields and a default value anchors the tool's parameter contract. The visible code below establishes an agent instance, registers a @agent_tool_plane function whose sole parameter is a Foobar instance, then runs it synchronously against a test model to surface the resulting tool definition schema through TestModel last model request parameters function tools.
From Pydantic import base model. From Pydantic AI import agent. From Pydantic AI models test import test model. Agent equals agent. Class Foobar base model. This is a Foobar. X int. Y str. Z float equals 3.14. @agent tool plane. Def Foobar str. Return strf. Test model equals test model. Result equals agent. Run sync hello. Model equals test model. Print result, output. Foobar, x equals 0, y equals az. Printest model, last model request parameters, function tools. Tool definition. Name equals Foobar. Parameters JSON schema equals. Properties. X type integer. Y type string. Z default 3.14 type number. Required X Y. Title Foobar. Type object. Description equals this is a Foobar.
When a tool's single parameter is a Pydantic model, Pydantic AI flattens the schema to that model's structure rather than wrapping it. The @agent tool plane decorator registers Foobar with the agent, and TestModel lets you inspect last model request parameters function tools to see the generated tool definition, name, description from the model's docstring, and parameters JSON schema with properties, types, defaults, and required fields derived from Foobar. This is the cleanest way to define structured tool inputs, keeping validation at the model layer and letting the agent framework handle schema generation. The trade-off is that you lose per parameter docstring granularity since the whole model becomes the schema, but you gain type safety and the ability to reuse the same model across tools or contexts. TestModel is specifically useful for debugging the wire format without hitting a real LLM. Let's break it down.
From Pydantic import base model. From Pydantic AI import agent.
Imports base model from Pydantic and agent from Pydantic AI. Provides the base model class and the central agent class for the application.
Agent equals agent.
Instantiates a Pydantic AI agent with default settings and assigns it to the variable agent.
Class Foobar base model. This is a Foobar. X int. Y str. Z float equals 3.14.
Defines a Pydantic data model named Foobar with 3 fields. X as a required integer, Y as a required string, and Z as a float defaulting to 3.14.
@agent tool plane. Def Foobar str. Return strf.
Defines a tool named Foobar that takes a Foobar parameter and returns its string representation. Decorated with @agent tool plane to register it without agent context access.
TestModel equals TestModel. Result equals agent. Run sync hello. Model equals TestModel.
Instantiates a TestModel and assigns it to TestModel. Then invokes the agent's synchronous run method with the prompt hello, explicitly passing that TestModel instance storing the returned result object. That's the whole pattern. A Pydantic model defines the contract. At agent tool plane flattens it into a tool definition with name, description from the docstring, and a parameters JSON schema pulled straight from the model's fields, types, defaults, and required markers. TestModel then surfaces that tool definition through last model request parameters, function tools, so you can verify the wire format without touching a real LLM. The trade-off is real. You trade per parameter docstring granularity for type safety and the ability to reuse the same model across tools. It's a clean boundary between validation and schema generation.
The TestModel watches tool plane spin a Foobar into a schema. It never asked for itself.